Hello, viewers. Welcome again to the continuation. We are on episode 27 of static mechanics. In this episode, we will be treating three coplanar forces that are in equilibrium. Three, we talk about coplanar forces that are in equilibrium from the previous episode. Here we are referring to exactly three of them. So when a body is in equilibrium under a system of three forces only, the following can be used to resolve the forces or to make the problem a lot easier. We can use triangle of forces, we can use the Lami's theorem, and we can use the vector approach. And for the sake of this tutorial, we will be dealing with all our calculations in what Lami's theorem. We can also try that of the triangle of forces or vector approach and share your thoughts in the comment section. So now, the Lami's theorem states that if three forces acting at a point are in equilibrium, just like the definition said, then the magnitude of each force is proportional to the sine of the angle between the other two forces. This will be clear. It states that the magnitude of each forces, as is force 1, force 2, force 3, the magnitude of the forces is going to be proportional to the sine of the angle between the other two forces. So you can see, if I'm referring to force 1, what are the other two forces? The other two forces is force 2, force 3. What is the angle between them? The angle between them is beta. So force 1 is proportional to the sine of this angle. All right. If I am referring to force 2, which other forces am I having? I'm having force 1, force 3. What angle is between them? Gamma. So force 2 is proportional to the sine of gamma. Likewise, force 3 to alpha. All right. Then that's Lami's theorem is the special version of sine rule. You know, the sine rule is the side of the triangle divided by the angle, the sine of the angle facing that side equals to the other proportional side. So if you consider force 1, force 2, force 3 acting at a point, then we can be able to say this. Then what will be the mathematical version of what we just explained here? That will imply that the force 1 divided by the angle between the two of them is going to be the sine 180 minus the angle between the other two is beta, equals to force 2 equals to the sine 180 minus the angle between force 1, force 3, that is gamma, and this will be equals to the force 3, which is also the sine of 180 minus alpha. Now, this is what we are having. Remember, we need to find the angle between them using the Cartesian plane, where we use the 90, 180, and so to get those values. Now, this is a compound angle for the sine. So it's going to be sine 180 cos gamma minus cos 180 sine gamma. And if you expand that, knowing that sine 180 is 0, you'll be having cos 180 as negative 1. The answer will just mean. So this is simplified as just force 1 divided by sine of beta equals to force 2, the sine of gamma equals to force 3, the sine of alpha. Remember, we don't need all the three. All that we need is if I have one of the angle that is between the two sides and one of the force is given, then I can use it to find the other force that I'm looking for. So I can equate force 1, force 2 if I know the angle and I know that of the force. I can equate it to find that. I can equate 1 and 3 also. We just say that this is the proportions that we have. We can take a question and text this theorem. Okay, so look at this question here. A 3 kilogram mass is supported by 2 strings, each inclined at an angle of 60 degrees to the horizontal. So if the system is in equilibrium, we have to find the tension in each string. So let's see, we have the mass is here. This is the body. To support this by a string, it is going to go up. So we can have a string. Then we can also have a string holding it towards this direction. Okay, so as the string is attached here, it will be attached to a support. Definitely there will be a support. The string cannot be in space. So if there's a support, that support is a horizontal, we are calling, not drawn to scale, so the diagram should not be okay. So if I have this is a horizontal. The angle it formed here is given to us as 60 inclined, so that is it. Then this will be the first string with tension 1. The second string we have tension 2. Now when the body is hanging, definitely there will be the weight of the body will be what? Moving downward. So we can also indicate the weight. Let me just use. So let's drain this. All right. So the weight will also be going down, and the mass of the body is so let's say this is the weight, and the mass of the body is 3. So 3 times 10, that will be 30 what? Newton. Now let's see if we can resolve the angle here. So let's see, we are having a parallel line there. This line is parallel to this. Then we can say that the angle here will also be 60 degree by alternate angle property. Then this is also equals to this angle here, 60 degrees. Then angles on a straight line. When angles on a straight line, their sum add up to 180. So 60 plus 60, 120 from 180. Here will also be 60 as well. So now that we are able to do this as a representation of what the question is saying, we can see that can be redrawn as the Lami's theorem we discussed at the entry introduction. So this is going to be the first force that we have, which is tension 1. The second force we have is tension 2. The third force is what? W, which we have as 30 Newton. All right. Now we need to know the angle between tension 1, tension 2, which is labeled there as 60. We need the angle between tension 1 and W. Remember, as this line is perpendicular to the weight, here will be 90 degrees. 90 plus 60, so give you 150. 150 plus 150 is 300 plus this. So here will also be 150, since this is angles meeting at the point. You can see 60 and 90. So what do? We go straight forward using Lami's theorem. What do we have? We are picking the tension 1. So let's pick tension 1 divided by the sine of the angle between them. Between tension 2 and W is 150. Since we know this, let's keep the 30 divided by the angle between T1, T2 will be 60. So we can do this. Instead of finding this in decimal, we maintain them and cross multiply. This will give you T1 times sine 60 degree equals to 30 times sine 150 degree. Because we are looking for T1, we divide by sine 60. So T1 equals to 30 sine 150 divided by sine 60 degree. Although we cannot cancel the sine out, and this cannot go there, or this canceling there. You put all in your calculator and check the value as a whole. And if you do so, you should be having 17.32 Newton. Now we are looking for the two tension, right? This is tension 1, tension 2. If the angle here is different from here, the value for tension 2 will be different. But you can see they are the same. So here, the tension, so we can only conclude and say that the tension in each string is 17.32 Newton. This is so because the angles are the same. If the angles are different, then we have to follow through the same procedure again and find for tension 2, which will be T2 over sine 150 equals to 30 over what? Sine 60, which will still come back to give you the same answer. I guess concept is clear. Like, share, comment, and subscribe.